So one of the most important concepts we're going to see for the rest of the semester is how sea level changes and how that affects what we see in the rocks. Hopefully you pay enough attention to modern science and you know that we are definitely very worried about sea level rise. So that definitely tells you, right, that our sea level changes, right, over time. Sea level can rise, sea level can fall. So let's take a look at what that's going to look like in the rock record, because this is something you're going to see over and over again. And if this is one of those concepts that if you understand it, you're going to understand a whole lot about what we're going to talk about for the whole rest of the semester. So be sure that you get this. So, the first one I want to talk about is a sea level rise. A sea level rise is what we call a transgression. So let's take a look at what a transgression looks like, and then we're going to talk about why it happens. So let's say here I am, right, at my continental margin, right? I'm standing out here on the beach, grading your papers, right? And this is my environment, right? You can see here we have our continental shelf, our slope, our rise, and the abyssal plain. So the four environments that are represented, right, are the beach, the shallow marine, the reef, and the deep marine. So if let's say now sea level is going to rise. So if sea level rises and I'm standing here on the beach, right, well, what's going to happen? Is that beach going to stay there or is it going to migrate? Hopefully you recognize that it's going to migrate. So let's pay attention. We're going to pay attention right here, right, at time 1. So when sea level rises, this is what our environment's now going to look like. So where the beach was, now that's shallow marine, right? And the beach has migrated landward, right? We're losing land. So at time 1, we have our beach environment, and the beach is represented by sandstone, which is a pretty big grain, pretty large size grain sediment. Time 2, we have shallow marine. Shallow marine is represented by shale, right, which shale is clay-sized particles. So these are very small particles. Now let's say our sea level is going to transgress one more time. So if it transgresses one more time, we can see that, right, the beach continues to move landward, and where I was at the beach, that turned to shallow marine is now a reef, right? So if we take a look at what this looks like down here, we see we've got my large grain on the bottom, followed by shale, and then the reef, the limestone, is my smallest size sediment. So the way I can recognize a transgression in the rock record, right, if I'm, say, walking around the Grand Canyon and I'm taking a look at the rocks, and I notice I have what's called a fining upward sequence, meaning my grain size gets smaller as I move up, right? We have large to small. That tells me that's a transgression. The deeper the water, right, the smaller the particle size, right? The deeper the water, the slower the water moves. So that allows those small grain sizes to get deposited out. Right? At the beach, there's a lot of energy there, so only your bigger grain sizes are going to get deposited at the beach. So, a transgression is a sea level rise. So, what causes this? This is the important part. If we go back to the beginning here, sorry for flipping back and forth. Here's the important part of this. So, what causes a transgression? Well, let's think about this, right? What are we worried about making sea level rise today? Hopefully you realize that's the melting of the polar ice caps. So when glaciers melt, that causes sea level to rise. Now, if we go back a billion years, we can see transgressions. So obviously man wasn't around making the glaciers melt. So what would make a glacier melt? So this is another important thing that we need to think about and realize. So if humans aren't around, okay, what's making the glacier melt is continental movement, right? My continents physically moving around the globe. So again, think about this. Where do we find glaciers today, right? Big glaciers. Well, we find them near the North and the South Pole. So the continent that's there, let's say Antarctica, right, it's over the pole so it can support a glacier. if Antarctica were to move off of the South Pole, what would happen to that glacier? Oh, hopefully you recognize it would melt, right? So this is going to be the big thing that's going to govern, right, our sea level changes, our sea level fluctuations over time, is where our continents are in relation to the pole. So that's going to be very important. All right. Now let's take a look at the other one, and this is a regression. So a regression is a sea level drop. This is where we gain land. Okay. So if we want to go ahead and tie that together, it's going to be opposite of a transgression. So a regression is caused when the glaciers get bigger, right? So as my continents move onto the pole, glaciers get very, very large, and it locks up all of that water into the ice cap, therefore making sea level lower. So let's see what a regression looks like in the rock record. So here I am, right? I'm at the same continental margin. Let's say I'm out here scuba diving, right, looking at some fish, and all right, so I'm in the reef, so this is going to be my time 1. Okay, so remember, the limestone is the smallest grain size. So now let's make it regress. So if it regresses, again, that means the beach is migrating oceanward, so we're gaining land. So there we are at time 2, right? We can see that the beach has migrated. So now we can see where I was at the reef. Now I'm at the shallow marine, right, which is represented by shale, which is pretty small, but it's larger grain size than limestone. Now let's make it regress one more time. And when it regresses one more time, now we see that we've got the beach on top, right, of everything. So this is quite the opposite of a transgression. This is called a coarsening upward sequence, where I have my small grain size on the bottom, and I have my larger grain size on the top. So when I see that in the rock record, that's telling me it's a regression. That's telling me that the Earth is going into a period where things are getting colder, because I have a continent over the pole, and my glaciers are getting bigger. So I can make these huge global statements by just looking at these specifics in the rocks. Now, we also have to realize that the way that things move, okay, and when we looked at these pictures, I kind of drew it here, but this picture draws a little better. Realize that when the beaches move, okay, it's not a stepwise thing. It's not like, right, here's the beach, and then it moves, and here's the beach, and here's the beach. It's moving throughout the whole thing. So you can see how I have this grain, this sand grain, going all the way from here all the way up. That's what we call Walther's law, right? That the deposit's happening continuously. It's not a stopping and a starting of the deposition.